Hello YouTube and welcome to another video. Today I'll be talking about the square root function and graphing its transformations. So today we're going to be learning about a new type of function, and this is going to be the square root function. So let's get straight into it. So to start off, let's actually figure out what exactly is a square root function, or in other words, the base square root function. So here I have the base square root function graphed, and the equation for it is just y is equal to the square root of x, or f of x is equal to the square root of x. And I have it listed right here. So let's start off by picking out some x values and see what they map to on the y. So notice here on this base function, there is no negative values. In other words, the domain, it doesn't go into the negatives. So right off the bat, let's just identify the domain and range. And let's start off with the domain first. So it looks like to me it starts at 0, and then it keeps going on to infinity. So we can write the domain as 0 to infinity. And this will make more sense a bit later, and also I'll include the range later on as well. But let's start by picking out some x values. So let's start with 0 here. And if we input 0 into our square root function, we're going to get 0 as our y because the square root of 0 is just 0. So you can say 0 here. Now what about 1? Same thing, if we input 1 into our function, we're going to get output 1 because the square root of 1 is just 1. And there we go. Now let's keep going. I'm going to jump to 4 because 4 seems like an easy number to take the square root of, and that should be 2. And lastly, let's pick out one more point. Let's say the 9 because 9 is pretty easy to take the square root of, so you can say 3. So notice how each of our x values, we're just taking the square root because that's just what we're doing. In other words, our function here, f of x, let's say we wanted to pick the point f of 4, then we're just going to be taking the square root of 4, and that's just going to be equal to 2. So we can actually identify some points over here. So I'm looking at the points. Let's identify the points we just sketched out. So the point 0, 0, the point 1, 1, the point 4, 2, the point 9, 3. So these are all pretty identifiable points on the base square root function. So now let's move on to the domain and range. So for the domain, it makes sense we include 0 and we go up to infinity because there is no upper bound on the y value you can ever hit. We can keep increasing our x and our y will just increase. In other words, the square root of whatever we're taking will just increase as we increase the x value. So this will go to infinity. And what about the range here? And the range, it seems like it starts at 0 because we can't have anything less than 0. And it looks like it's going up to infinity as well. So we can say it goes up to infinity because there is no limit to how high this function, how high the y values can go up to. And there we go. And yeah, and also for the domain, I meant to say for the x values, there is no x value that we can stop at. We can keep increasing our x down to infinity over here. And same thing with the y, it'll just keep increasing on and on. So yeah, those are domain and range. Hopefully that makes sense. Let's move on to some transformations. So given the base square root function f of x, graph g of x is equal to 2 times f of x minus 1 minus 2. Okay, so in order to apply transformations to your base square root function, you always want to transform your identifiable points. And your identifiable points in this case are going to be the points, like we pointed out, 0, 0, 1, 1. What else is there? There's 4, 2, and there is 9, 3. So you always want to transform these points over here as they will be easiest to work with as they're nice whole numbers. Okay, so again, if you remember from the transformations unit, we always want to start off with the vertical stretch and reflection. So let's do that really quick. So I'm noticing here we do not have a reflection, so we're just going to stick with the vertical stretch. So we're going to multiply all of our y values by 2 here. So the point 1, 1 will be transformed to the point 1, 2 because all we did was multiply our y value by 2. So we can write this in. The point 1, 1 gets mapped to 1, 2 because we just multiplied this by 2. And same thing for our point 4, 2. That's going to be at now 4, 4 because we're just multiplying the y value by 2. So the point 4, 2 gets transformed into 4, 4. Just multiply this by 2 for our vertical stretch, and so on. Let's do one more point here. Let's say the points 9, 3 are identifiable point. That's going to go down now to 9, 6 over here. And 0 stays the same because 0 times 2 is going to be 0. So we can actually write this in, draw this in. So it'll look something like this. That should be connected. And there is 2 times f of x. So we just applied the vertical stretch. So now let's apply some translations. Looks like we don't have any horizontal stretches or reflections, so we're just going to go straight to our translations. So we're going to move this point, move our points left 1 unit, right 1 unit, and down 2 units. So we're going to go right 1 unit. So from the point 0, 0, we're going to go to right 1 and then down 2. So we're going to go over here. Same thing with our point 1, 2. We're going to go right 1 unit and down 2. So we need to go right over here. I want to make sure if I'm doing this right. Looks like I am. Okay, let's move on to the next one. The point 4, 4 will now be at the point 5, 2, 2, 5. There we go. So just move right 1 unit and then down 2. And lastly, for our point 9, 9, 6, it's going to go to 10, 4, 4, 10. I say backwards, but you get the idea. And let me erase these dots I drew. And our final transform function looks something like this right here. Let me draw the line a bit neat. And there we go. We can write this in. G of x is equal to f of x minus 1 minus 2. And there we go. That's all you have to do. Let's move on to the last question here. This one's a bit of a tricky one as we got a lot of transformations to work with. So it asks us, given the basic square root function f of x, graph the function g of x is equal to minus 3 times f of minus 2 times x plus 1 plus 1. Okay, so since there are a lot of transformations here, I'm going to start off by identifying them. So this is going to be a vertical stretch by a factor of 3, and it's going to be a vertical reflection. There we go. And this is a horizontal stretch, and it's also a horizontal reflection because notice the negative sign here on both of these. So there's going to be 2 reflections we're dealing with. And we're also going to be going left 1 unit because it's the x plus 1. And we're also going to be going up 1. So again, let's start off with doing the vertical stretch and vertical reflection first. So at the point 0, 0, that's going to remain the same because 0 times 3 is that, and we can't really reflect it because it's right at the origin. So let's move on to the point 1, 1. So where's the point 1, 1 going to go for a vertical stretch and reflection? So the point 1, 1. Once we apply the stretch, it's going to go to 1, 3. And since we're reflecting everything, our y will be negative because it's going to be a reflection across the x-axis. So we can transform the point 1, 1 down to 1, negative 3 right there. And the same thing for the point 4, 2. The point 4, 2 is going to go to, you write that in, 4, 2. It's going to be transformed into 4, 6. But since we're reflecting as well, we're going to do negative 6. Because all I did was I multiplied the y value by 3, negative 3, because we're reflecting across the x-axis as well. So let's write that point in. So it's going to be at 4, negative 6 right there. And let's do one more point. Let's do the point 9, 3. So it's going to be over here, 9, 3. So the point 9, 3 is going to go to point, keep the x the same since we're only doing the vertical stretch first. It's going to go to 9, negative 9 because we multiplied this by negative 3. Multiply by negative 3. Okay, there we go. So let's draw that in. It's going to go to 9, negative 9 right over there. So let's draw that in really quickly. Let's include the arrow. So this is our function y is equal to negative 3 times the square root of x. So now that we have applied our vertical stretch and reflection, let's deal with our horizontal stretch and horizontal reflection. So before I do anything, I'm just going to erase this over here to make myself some space. Let's see what color I want to work with. Let's say I want to work with, blue seems good. So let's see what stretch this is our factor by. So we always want to do 1 over our horizontal stretch. So we can do 1 over 2. And it looks like it's a horizontal horizontal stretch by a factor of 1 over 2, because it's a stretch by a factor of our 1 over b value. So all we're going to be doing is we're going to be multiplying all of our x values by 1 over 2 while also keeping our y value the same. And we're also going to be reflecting. So if I look at the point 0, 0, I think it's going to stay at the origin here. It's not going to be affected because we can't really have our x value in this case. And it's going to stay right there. And also reflections don't apply because that's at the origin. So let's move on to another point. Let's say now, since we're working with this function down here, this is at the point 1, negative 3. So the point 1, comma, negative 3, since we're going to be halving our x value, this is going to transform to the points 0.5, comma, negative 3. And since we're reflecting as well, it's a horizontal reflection. Let me write that in. It's a plus horizontal reflection, where we're going to reflect across the y-axis. Horizontal reflection, yeah. So it's going to be a negative 0.5, negative 3. So we can actually draw that point in. So that's going to be at negative 0.5 and negative 3. That's going to be somewhere right there. Perfect. Let's move on to the point 4, negative 6. 4, comma, negative 6. And all we're going to be doing is halving our x value because it's a horizontal stretch by a factor of 1 over 2. So now it's going to be at 4 divided by 2. That is a 2, comma, negative 6. And since we're also reflecting, we're going to include a negative here. So it's a reflection across the y-axis. And all I did was a multiplied by a factor of 1 over 2. And there we go. So let's draw on that point now. So negative 2, negative 6. It's going to go to negative 2, negative 6 right over there. And lastly, for our point 9, negative 9, it's going to be at 9, comma, negative 9. That's going to transform over to, see the point, it's going to be at 4.5 because we're just halving our x and keeping the y the same. And remember, don't forget to include that negative since we're dealing with a reflection. So that's going to be at negative 4.5, negative 9. So it's going to be right over here. Perfect. Okay, that is 4.5, right? Yes, it is. So we can actually draw this in now. So this new function is now going to be y is equal to negative 3 times the square root of, let me actually draw this down here. I have more space. Y is equal to the negative 3 times the square root of, what do we have? Negative 2x. There we go. So now that we've applied our horizontal stretch and reflection as well as our vertical stretch and reflection, we can deal with our translations now. So the hard part's out of the way. Now all we have to do is move our function left 1 unit and up 1 unit. And I'm going to be doing this in the color orange. So start off with the point 0, 0. So left 1 units is going to be right there, and up 1 unit is going to be right over there. Perfect. And same thing with the point negative 0.5, negative 3. We're going to go to negative 1.5, and we're going to go up 1 unit. So it's going to be right over there. Okay. And this point right here, negative 2, negative 6, that's going to go to negative 3, negative 5, right over there. And lastly, our points, negative 4.5, and negative 9 is going to go to negative 5.5, and negative 8. And there we go. We can actually sketch this in right over here and include an arrow. And there we go. We are done. Now, I know the question doesn't state state the domain and range, but why don't we just do it for fun? It's good practice, and also it builds your math skills. So for the domain, looks like we're going to be going from negative infinity to, what is that, negative 1. And for the range, looks like we're going to be going from negative infinity to the point 1. And there we go. That is how you graph radical functions with transformations. See you in the next video.